Okay. The Borg have just assimilated species number 4782, and their cube is expanding at a rate of 100 cubic meters per second. What is the rate of change of the surface area of their ship? What do Borg spaceships always look like? Cubes. It's called a Borg cube. Sure, cubes. They expand. Oh, the Borg. All shows, all sci-fi things, all horror things are only as good as their villains. The villain sucks. Nobody cares. The villain has to be a good villain. It has to be a good bad guy. You have to be genuinely afraid of the villain. The Borg was one of the best Star Trek villains ever. The only one I liked better than the Borg was Q. But that's me. Okay. So, and I have my favorite Borg quote. We are the Borg. Lower your shields and surrender your ships. We will adapt your biological and technological distinctiveness to our own. Your culture will adapt to serve us. Resistance is futile. Okay. So, what information are we given? The cube is expanding at a rate of, so that would be a rate. Rate means that it's the derivative portion. And cubic meters per second would be a volume. So that means that dV dt is equal to 100 meters cubed per second. You know, I did actually forget. I meant to fix this. I forgot to fix this. What is the rate of change of the surface area of the ship? Well, there's a particular thing that's missing, and I'll give that in a second. What? You need to know it at a particular time because you can find it in relationship to something else. But what you need to know is you need to do it at a particular time. But we'll kind of get to that in a second, and you'll see why something is missing. Okay. Once again, what is the shape of their ship? It's a cube. So the volume, the formula for the volume of a cube is its edge length cubed. Okay, X, we'll call it X because I can use S, but when you handwrite S for side length, it looks like a 5, so that sucks. So I don't want to use E for edge because we actually use E in this class, right? I don't want to do that. Okay, so we'll use X, even though it's not necessarily really the best variable in this particular case, but it works. What am I being asked to find? Change in surface area. I'm looking for ds dt. But wait a minute, I have the volume related to the edge length, not surface area. So I got an issue here, don't I? Can I go directly from volume to surface area? Not really. You kind of can, but boy, it's going to be something really ugly. Okay, you can solve for surface area in terms of the edge length, or surface area, you know, the edge length of this. If I know the surface area, what's the edge length, and then put it in, trust me, be very, very ugly in a hurry. Be very ugly in a hurry. What's actually better than finding the SDT, because you can't do it directly. Because if I take the derivative of this, what do I get? dV dt is equal to 3x squared dx dt. Okay. Not ds. But I can solve that for dx dt. And then say, okay, go back and find ds dt. Because what's the formula for surface area? Surface area of a cube. 6 what? 6x squared. So if I want to find the rate of change of the surface area, ds dt is equal to equal to 12x dx dt. So if I can find dx dt here, I can use that in here. Okay? If I can find dx dt here, I can use it to find ds dt here. Sometimes you have to do that. You can't go straight from the given information to what you're looking for. You kind of have to go a circular kind of route, so to speak. Okay. Now, there is one important thing that's missing here. When x is equal to, or when the edge length is, or when it's so many feet across, I need to give what the edge length is. Because if you go back and look at the previous one, I said, find the HDT when h is 3. You need to know the instant you're talking about how big is the cube. I need to be able to find my value for x to be able to find it, because technically, how many variables do I have in here? I've got 1, 2, 3. I'm only given the value for 1. I need to have the value of all but 1, right? So, my bad. This is an imperfect problem here. Okay, does that make sense? So when the ship is 150 meters across, which is not very big. It's a little baby Borg ship. Well, you wouldn't have a lot of Borg on a Borg ship that's only 150 meters across on one edge. Right? That's a football field and a half, a little more than a football field and a half. It's not very big. Not for a Borg ship. Okay. Yes, I am a nerd.
I just signed again. I forgot the one for the 12x.
Did I? Oh, you're right. My bad. Okay, so here's what I want you to do. I've given you the derivatives. I've given you the problems. Find dSdt. Take a minute. Find dSdt. I've given you the derivatives. We went over the equations together. Plug in the values. Plug them in the appropriate places. Find dSdt. Go ahead and finish this one off. So we have 2 problems here, right? We have this one we have to do. So dV dt is 100 and it's increasing. So that's 100, and I'm not going to worry about units, equals 3 times 150 squared dx dt, right? So 150 squared is 21,500. 22, yes. 22,500 times 3. 67,500. 100 divided by that. What do you get? Give me the decimal, because it does make sense to have the decimal in this one. Come on. I'm recording here and you're making me stand here and wait. It sounds so bad that nobody can shout out a decimal of 100 divided by 66,750. 0.0014 equals dx dt. Okay, thank you. So that's dx dt. Now we need to find ds dt. So ds dt is equal to 12 times 150 times 0.0014. So multiply those all out. What do we get? 2.66 meters per second, or square meters per second. That's what it is. Okay. 8/3. Okay? Questions? Your turn. Okay. So let's take a look at this. Okay. So our given information. The head is decreasing at a rate of 3 cubic inches per minute. So that means that dV dt, negative 3 cubic inches per minute. Okay. We're dealing with a sphere. We have the formula for a sphere, for the volume of the sphere. How fast is the diameter changing? dd dt is what when the diameter is 10 inches across, and again when the diameter is 8 inches across. So you have to actually have two problems here. One that's 10, one that's 8. That's kind of want to show something by having two different answers here. Now, I have an issue. The formula is given in terms of radius, but I'm asking for diameter. I have two choices. I can convert the diameter to radii and do it then, but then I have to change dr dt to dd dt. Or I can very easily change the radius to diameter and put that in, which is what I would do. Now, if you didn't, it should still work out the same in the end. At least, you'll have to make adjustments. So I'm going to change the diameter to the volume in terms of radius, in terms of diameter. But the radius is equal to what? 1/2 the diameter, right? So R equals D over 2. So that means the volume is 4/3 pi D over 2 cubed. Okay. 2 cubed is 8. 4/3 times 1 over 8. So my volume is 2/3 pi D cubed, because it reduces down. It's not a very difficult thing to do. Now I have things in terms of diameter instead of terms of radius. Okay. So I go ahead and take the derivative. dV dt is equal to, bring down the 3, so I get 2 pi d squared dd dt. Right? Because I bring down the power, reduced by 1. 3 times 2/3 is 2. Okay, pi r squared. Okay, pi d squared, sorry. And now I start plugging in values. All I have to do from here is evaluate. I want to evaluate. So I have to do it twice. So I have negative 3 is equal to 2 pi times, and I do it when it's 10 squared dd dt. And then I have the same thing again. Negative 3 equals 2 pi 8 squared dd dt. So I end up with negative 10 squared is 100, 200, so that's negative 3 over 200 pi dd dt. 8 squared is 64. 64 times 2 is 128, right? So I get negative 3 over 128 pi equals dd dt. Now, if you did that in terms of radius, and you got dr dt, you have to double it. Because think about it. The diameter is increasing this way, but if I talk the radius, it only increases one direction, but I also need to increase the other direction on the radii, because I have two radii making a diameter, so the radii increases this way and increases this way, diameter increases out, radius only increases in one direction, so I have to have both of them. So if you take what you got for the radius and double it, that's what you should have. The equivalent of that. Okay? Questions? Okay. Okay, let's start the recording again because I screwed up. So this becomes, instead of 1/6, this becomes 1/2. Right? So that means, so this is 1/2 here, this is 1/2 here. So that means, instead of that, basically take half of this bottom down here. So that's 100 pi. And I do half of this, which is 60. Actually, no, I need to take 1/4 of it because I doubled it and I need to take 1/4 of it. My bad. So this ends up becoming, no, you're right. 50 pi. And this one becomes 32 pi. 100 squared, half of that's 50. That's 50. Yeah, that should be 50. Because I take 100 squared, what do I get? 10 squared, I get 100. 100 times 1/2 is 50. Okay.
I just did the radius way and I got -3/.
What did you use for the measure of your radius? Did you use 5 or did you use 10? Okay. 5 squared is 25. Half of that is 12.5. When you do the derivative here, this should be 1/6.
No, it'll be different because it doesn't have the over 2.
Doesn't have the over 2.
Yeah.
But it still should end up, if you double it, you should still end up with the same
I
thing.
got the same.
Yeah.
The radius one.
You did?
Exactly. We got the exact same. We had to plug it into dt equals 2 drdt.
Okay.
drdt into that, and you get d.
Oh, okay. That's what you did. All right. Okay. So, okay. So yeah, if you do the radius, it still ends up working out the same way. So, questions? Okay, now we're done.